Okay, this video is a review of graphs of functions from 3.1 to 3.2 and also the average rate of change for functions. What you see here is examples referencing a piecewise function. So piecewise just means that the graph is separated apart to different pieces depending on the domain. So it's a little bit trickier than just having one continuous type of curve or function on there. Well, we have to decide if this is a function. So why don't you take a look at that, see if you can answer some of the questions already, like A is f of function, B is find f of 0, f of 7, f of 2. So those are familiar things to you. Find f of 7 minus f of 5 over 2. You should recognize that as average rate of change. You're just, the change in x values is already calculated for you. And then can you solve for what values of x is f of x equals 0? When does it equal 2.5 and 6? And then we'll talk about the domain and the inequality symbols for part D once you try that. So go ahead and pause the video and try it, and then we'll talk about it. Okay, so hopefully you had a chance to dive into that a little bit. As always, just if you're not comfortable with doing it on your own, or you reach a point where you're stuck, then just, get back to the video and I'll do it along with you. Most of them I do out, or at least have the solutions there. So is this a function? So we can use the vertical line test, and we use this little laser pointer. At any point I go down through, I only hit once. The spots you need to be careful of are here where the input is 7. This is an f of x function, so we can just say when x is 7, the line goes through kind of 2 spots. However, one of them, the spots at the y is -1, that's an open circle. So it still is a function. It passes that vertical line test. So we're okay there. So yes, it's a function. F of 0, if we start at 0 and travel up and hit the graph, then look to the left, we have 2. F of 7. So here's my 7. Look left. Actually, let's see. That one is an open circle, so that won't work. We won't have anything there. It doesn't really lead us to 1. So we have to kind of go through that one and up here to the solid dot, and then over to the left, and we get 5. So be careful of that. So we're not going to write anything for this one. So skip right through it. F of 2. Now find where your x is 2. Going to travel up, and we hit an open circle. If we were to go through, there's no other solid dots or lines to hit. So we're going to say that it does not exist. Get rid of the equals. Does not exist. So there's no input that exists for that. So it's kind of a semantics, because I'm trying to find something or evaluate something rather than solve. So I write it does not exist, that input. F of 7 minus f of 5 over 2. So this, we might recognize that 2 being the difference of 7 and 5. So what I need to figure out is what is the value at f of 7, and I have that right above here. I can reuse that one right here. F of 7 is 5, so I'm going to go ahead and put that there. And f of 5 I hadn't already figured out, but I can do that pretty quickly. I'm going to look where x is 5, and it brings me up to 1. So then I would have 4 over 2 equals 2. So that you should recognize now as average rate of change. C, for what values of x is f of x equals 0? So now I'm going to use a different color here so we can look at when the y is 0, which would be the x-axis, that whole thing. And where does our graph hit this piece of a parabola? Looks like right there. So, and then I travel down to find my x value. Now it's a little hard to tell exactly. I'm going to write it as a fraction, maybe negative 2/3. So I'm going to say at x is about negative 2/3. That's my input. F of x equals 2.5. When does that happen? So I'm going to go to 2.5 and I'm going to draw a line all the way across. Remember, we've talked about this before. So that way you notice, you don't just kind of look at one, you notice all 3 spots that hits on. So then you would write at x is about, we have 1/3. We have, maybe that's 1 2/3. And this last one over here is maybe 5 2/3. We'll just kind of stick with our theme of thirds to keep them all matching. F of x equals 6. Let's see if we can find when that happens. So I would go up to where y is 6 and look for an x. There's no graph up there. There's no piece of the graph. So there is no solution. And I think here, f of 2, we talked about if we weren't led to any output from our input. I'm not sure if I worded that the way I wanted to, but I don't have any, there's no existing output. So we say does not exist. Now here, this is one that we're solving. So we would say no solution. We cannot solve it. There's no input for the output. In this one, there was no output for the input given. So that's a little bit of semantics there. Part D, for what values of x is f of x greater than 2? So now we need to look at where 2 hits, which is, I'm going to use this rust color. So we have 2 going across in that kind of rust color, orangey color. And what values of x is the graph above that? Okay, not including that. So it would be, let's kind of do a green highlighter. This section here, this little curve, and then also this segment here. Okay, I'm gonna get rid of that dot there. So I have to write the interval where it hits through. So I would have x is, starts at 0, but I don't want to include that because I don't want to count where it actually hits on it. I want everything greater than that. And then we're going to travel over here and we have an open circle there. There's some of the stuff here. So that's an open circle. So it hits at 2, but it doesn't actually touch it because I want everything greater, and it's also an open circle. Then union, and at this point it's approximately 5.5. If I look down here, And again, I want everything above that, so I don't want to include it. About 5.5, all right. And then this dot up here, that last one is above, that whole thing's above, so I'm going to include the 7 as a bracket. So that would be my domain for anything above 2. When is f of x less than or equal to 0? So we have this purple line already drawn right here. I'm going to highlight it for a sec. Then I want to look at this segment here where it's less than or equal to, so I'm going to include the equals. So that would be -1, and that one would be included anyway. And the negative, let's see, the next little piece is right about here, so -2/3. And that one, again, I'm going to include because it said or equal to, union, and then I have the other little bit is over here. And if we look down, we have 7, but it's an open circle, so we can't include that. And we have an arrow here on this segment, so we're going to say to positive infinity because this interval is continue on and on and on to the right. What is the domain of f? So I'm going to get rid of a lot of these lines here so we have a clean plate to look at. And what is the range? So all together going across, can you kind of, not looking at what's less than or equal to like above, just figure out what x's are included in that graph that have a curve or a line or something represented. Okay, so beauty of a Surface Pro in an eraser. So we can have a fresh look here, and the domain of f, we're going to start here with a solid dot over when x is -1. So that is our first, the leftmost x value, and it's inclusive. We travel over along the interval until we get to +2. That's an open circle right up here. So I don't want to include the 2. Remember, this is my interval here going across. Then I'm going to have a union with this next piece here. So when I hit this as a solid dot, it leads to, or 4 is where that is my x value. And again, I want to have it a bracket, comma, and then I travel acrossways. And my interval, yes, the line's included there, kind of goes all the way over to 7. I have a solid dot up above, but this one's an open circle, but it's covered in that same thing. So the 7's there, so I can just kind of continue on. And then we have this arrow that goes off to infinity, positive infinity. So you don't need to write these separately. Like you don't need to go like 4, 7 with a bracket and then union open parentheses 7 to infinity. You can just go ahead and write the infinity with a parenthesis because that 7's covered in there. Sorry about that. That just zoomed in really big. So now we're going to look at the range, and that's going to be my up and down. So I want to look at how that lays out, and we haven't talked too much about this yet. So you'll get a lot more of this in pre-calc, but just to get you familiar. So what is the range of f? So if I am starting, look at my highest point up here, right? So that's my highest point, is that 7,5. So we have a y value of 5 is the highest, and it's actually included solid dot. I'm just going to write this a little further over. And then instead of going, up from there, I'm actually going to go down, because that's how my graph lays out. So that's my top cap. So I'm going to put a right bracket around that 5, and then figure out what's my lowest y value. Well, if I'm kind of looking down here, well, this arrow dictates that it just goes down and down to negative infinity. So I would write negative infinity. Sorry for the beeping. That's my oven timer. Make it easy at home. So we have a curved bracket, negative infinity, comma 5, with a closed off bracket to show that 5's included. So I think that's takes a little getting used to having that vertical approach for the range, but just practice it. So let's go on to the next part here, graphs of functions. We just touch on this a little bit. A function is increasing if its y value increases as its x value increases, and decreasing if its y value decreases as its x value increases. A function is concave up if its bend opens up, and concave down if its bend opens down. So let's just really quickly look at number 2 here. This would be those increasing, and it's concave down. It's kind of like if it were a bowl, all this stuff would fall out. Okay, so we have increasing and concave down. So this one on the right hand side is also increasing from left to right. We'd go up, and the bowl would be filled. The stuff wouldn't dump out, so it's going to be concave up. Okay, this curve in the left-hand corner is from left to right. It's decreasing, but also the bowl would stay filled. So we have decreasing, and that would be concave up. And see if you can figure out the last one there on your own. And the last one is decreasing, and it is concave down. So make sure you read through the book. There's some more explanations. I'll also do an additional video that kind of is very similar, goes along more with the book. An inflection point is where the concavity of a graph changes. So I'm going to draw a little graph here for you to see. So just if I had, for example, if I had a graph that, here's my axes, x and y axes, and I'm just going to put a curve on here. And so it kind of goes like this. It's going down, and then I'm heading up, and then down and up again. Okay.
I love you too.
Okay, so the inflection point is where it changes. It's not the actual curve itself. It's where it switches. So I'm decreasing here, and then I start increasing, and it's like kind of this midpoint right in there, and then it switches over. So it's like kind of where the bowl would tip. So this is my point of inflection right about here. And again, you don't have to be exact for that, but you can kind of see where the bowl would be filled, and then you can look at where it's all going to fall out. So where that switch happens, that's the point of inflection. And then we can also look at the local maximum is at a point whose y value is at least as large as all nearby y values, and a local minimum at a point whose y value is at least as small as all nearby y values. So here's another graph, and for instance, if it looks like this, I can go up and down as a low spot, and then I go high again and down. This would be my local minimum, would be right here. And my inflection point, just to reiterate that, is kind of right about here. Just happens to be near the axis. And then this would be my max, my local max, that peak of that curve. And that's it for this video. So have a great night.